We have NaCl, known as sodium chloride, plus magnesium, Mg, SO4, that's sulfate. And this type of reaction is actually called a double replacement reaction. So in a double replacement reaction, all we really see is two compounds trading partners, and I'll elaborate what I mean by that. So in the first part, the sodium is the metal, and that's actually combining with the sulfate. So we get sodium sulfate, that's aqueous in solution. Now we're also gonna get the creation of another compound here. So the other metal, magnesium, combines with the other nonmetal, where we get magnesium chloride. But chloride is actually a -1 charge on it. So then we actually want this compound to have a net charge of 0. So what we want to do is, we know that magnesium has a charge of +2. So what we have to do is, actually we need 2 chlorine molecules. So we need 2 of those chlorine molecules in order to balance out the charges to get a net charge of 0, because the +2 with the -2 equals 0. So that's why we want 2 of the chlorine molecules here, or 2 chloride molecules here. So now this part is balanced. Now this one over here, the sodium sulfate, that's not balanced yet, because sodium has a charge of +1, while sulfate as a whole has a charge of -2. So remember, whenever you have an ionic compound that does not have a charge on it, we actually assume that it has a net charge of 0. So we need to actually do something to this sodium to actually make this equation true, this statement true. So what we want to do here is, we want to multiply this one by 2, where now we have a +2 and a -2. Well, that's equal to 0. So then we're saying that we need 2 sodiums here. So we need 2 sodiums there. So now this is going to be Na2, comma, or parentheses, SO4. Now that's a balanced compound. And then this is pretty much it. This is it, what you would do. Now the only thing left to do now is, what we want to do is, we'll get rid of some of this clutter first. We actually just want to balance the remainder of the equation. So let's look at the left side. So this arrow is what's going to distinguish the left side and the right side. On the left side we have 1 sodium. On the right side we have 2 sodium. So we have 1 sodium on the left and 2 sodiums on the right. So we actually want to put a 2 right here. So now we have 2 sodiums on both the left and the right side. So those are balanced. Now we have 2 times chlorine. That means we have 2 chlorines here on the left. So let's put that down. So we have 2 chlorines. So 2 chlorines. On the right side we have 2 chlorines as well. So we have 2 chlorines as well. Now the chlorines are balanced, 2 and 2. Now we move on to the magnesium. So on the left side we have 1 magnesium. So let's put that down. So we have 1 magnesium, 1 Mg. On the right side we also have 1 magnesium. So thus far the magnesiums are balanced. 1 magnesium on the left, 1 magnesium on the right. Now, there's a little shortcut that I like to take here. So, we know that here in this compound we have SO4. That's known as sulfate. So, we have just one SO4. On this side, we also only have one SO4. So, let's put that down. So, we have one SO4 on the left side. On the right side, we also have just one SO4. The longer way to actually balance this would be to say we have one sulfur on the left, one sulfur on the right, 4 oxygens on the left, and 4 oxygens on the right. But we could actually skip that step and just go straight to say that we have one SO4 on the left and one SO4 on the right. Either way would work, you're just saving an extra step.